Hello everyone, let's introduce our case studies of forestry and urban tree management projects. Forestry Tasmania is Australia's biggest forestry operator and handles approximately 3.5 Miohav plantations and native forests. In 2008, Forestry Tasmania contracted Dimap to fly a test area of 6,000 hectares with the full waveform LiDAR to develop optimized taxation procedure of the forest using LiDAR technology. To reduce the taxation costs and get full area taxations with faster turnaround times of the data. The solution should also provide additional data layer for other departments like harvesting planning. Dimap applied the Regal 560 full waveform scanner together with a digital camera to fly the steep mountain terrain in central Tasmania, generating more than 4 points SQM. And an ortho photo with a resolution of 10 centimeters, while Forestry Tasmania collected traditional plot data for the different forest structures. During the processing, Dimap provided not only the images, intensity images, lost point files, DTM and DSM, but also full waveform data and statistically summarized waveform data. Describing the forest in more details. The ground plot data were then used to calibrate the LiDAR data and calculate top and mean heights, basal area per hectare, and stem volumes with better than 90% accuracies. Furthermore, the segmentation of the forests and additional data layer for the GIS system run by Forestry Tasmania were calculated. The stratification of the forests could be analyzed as well as fuel load as part of the forest fire prevention. The technology allowed Forestry Tasmania to reduce the manual field effort for taxations by 80% and ended in a setup to collect taxation data for the 3.5 Mioha. Based on airborne full waveform LiDAR within a 3-year project, the technology replaced the classical ground-based taxation approach completely and is established as standard operation procedure. During the project, Dimap also found the tallest tree Australia's with over 100 m height. On the other case studies, Dead Sea potash production, dike stability, and water seepages. Due to the geological conditions, the descent of the water level of the Dead Sea, the dissolving of underground salt layers, and the influence of the potash production south of Dead Sea sinking processes, endangering the stability of dikes along the ponds for the potash production. Sinkholes and dike collapses, causing multi-million-dollar damages in the production facilities on the Israeli and Jordan site. Potash producers and external geotechnical consultants were requesting a multi-sensory data set to get a more comprehensive data set to forecast problem areas and the development of long-term strategies. Dimap and the Israeli partner OFEC applied in a multi-day flight operation over the area with the more than 400 SQKM, a combination of multiple sensors. The flight operations were supported by GPS and thermal ground truthing, and the heritage data of the client provided further material during the analysis. All data were produced GIS, ready to support a multivariate analysis using a scoring system for a fast and efficient detection of problem zones. The LiDAR data allowed the fast identification of sinkholes and depressions. The data were accomplishing satellite radar interferometry results, allowing the identification of finer details than the satellite data. In a parallel analysis, thermal data were visually checked against the orthophoto mosaic and anomalies marked. The data allowed the detection of underground water and the mapping of seepages through the dike, as well as along fault lines. First work with the hyperspectral data allowed the discrimination of salt and carmelite, as well as identifications of salt structures in the ponds and water depth estimations. During the next steps, hotspots and unclear situations of the geotechnical analysis, like boiling points, will be further analyzed. Base for those work are field ground truthing and hyperspectral laboratory samples. In a final stage, the results of the individual problem areas were scored, summarized, and visualized in the GIS system. The data allow the identification of structural danger zones and are the base for engineering work on the dikes. Thanks for watching our videos. We will keep updating. For more details, please contact us in the following ways.